Okay, hi guys, welcome back to QBT. Today we are talking about current and voltage in parallel circuits. Okay, so depending on whether the circuit is parallel or in series, how current and voltage are distributed across each component is different. Okay, so we're doing two separate videos to talk about how it is in each circumstance. But let's talk about parallel circuits today. So in parallel circuits, the voltage that is supplied to the circuit is the same voltage across all of the components in the circuit. But current is a bit different. Current is split, it's shared in a parallel circuit, but cumulatively it adds up to the total that's gone in. So to make this make a bit more sense, why don't you check out the tutorial video that I've made, okay, and hopefully that clears some things up for you. Okay, let's have a think about how we might use our knowledge of how current and voltage is distributed in parallel circuits to answer this question. So, the question says, calculate the voltage across each resistor in the circuit below, as well as the total current flowing from the battery. So, it's flowing away from the battery, right? We want to find the total current that is coming from our battery. Well, the first part of the question asks us to calculate the voltage across each resistor. And because these are in parallel, because this is a parallel circuit, we know from our equation V in is equal to V1, which is equal to V2, which is equal to, and so on. We know that the voltage across each component is going to be the same, which means that if this is R1 and this is R2, resistor 1 and resistor 2, the voltage across R1 would be 23 volts, and the same applies for R2. Okay, good. So that's the first step. Good stuff. But how would we calculate the total current? How would we find that? Well, we know that in a parallel circuit, I total is equal to I1 plus I2 plus I3, and so on. So one way to find the total would arguably be to find the current across each resistor, each of the components, and add them together. And we can do that, right? Because we have the resistance, and we also now have the voltage. So we can use our equation. We can use ravioli, right? And we can rearrange this to find current, right? So we can say I1, which would be this one, resistor 1, is equal to its voltage divided by its resistance, which would equal 10 amps. And we can do this again for I2, right? We can say that it would be 23 divided by 4.6, okay? And we would get 5 amps. So we now have the current across each of our components. We can add that together to find the total current. So the current that is leaving the battery is equal to 15 amps, because 10 plus 5 is 15. And that is how we use our knowledge of how current and voltage are distributed in a parallel circuit to answer the following 4-mark question. Okay, so hopefully that helped you understand how current and voltage are distributed in a parallel circuit. If you want to learn a little bit more about current and voltage and resistance, then check out our other videos in our electricity topic. They are linked below. But in the meantime, yeah, I'll see you in the next video. Okay, bye guys.